Polynomials. What is a polynomial? 7 is such 3x square plus 2x, 5y cube plus 7y square plus y, 3x square plus 2x minus 3 are examples of polynomial. Based on the number of terms, we divide the polynomials into different categories. Expressions with only one term are called monomials. Expressions with two terms are called binomials. Expressions with three terms are called trinomial, and generally we call them as polynomials. Degree of a polynomial. If p of x is a polynomial in x, the highest power of x in p of x is called the degree of the polynomial. Based on the degree of a polynomial, we divide them into different categories. Linear polynomial. A polynomial of degree 1 is called a linear polynomial. Root 3x plus 5, 3z plus 4, 4y plus 3 are examples. Quadratic polynomial. A polynomial of degree 2 is called a quadratic polynomial. Y square minus 2, 2 minus 3z plus z square, x square plus root 3x are examples. Cubic polynomial. A polynomial of degree 3 is called a cubic polynomial. Y cube, 2 minus x cube, root 2x square, 3 minus y square minus y cube are examples. If a polynomial is of degree 4, we generally say that the degree is 4. If a polynomial is of degree n, then we say that nth degree polynomial. Geometrical meaning of the zeros of the polynomial. What do you mean by the zero of a polynomial? This we have come across in 9th standard. The real number k is a zero of the polynomial p of x if p of k is equal to 0. Why are the zeros so important? Let us see through few examples and their geometrical representation. Consider a linear polynomial ax plus b, a not equal to c. In this equation, x is a variable and a and b are constants. By giving different values for a and b, we will observe what happens to the graph. The graph of the linear equation y is equal to ax plus b is a straight line. This we have studied in the previous class. Now we are going to give different values for a and b and what happens to the graph. That only we are going to see. Here already in the given condition a is given as not equal to 0. Therefore we will give a particular value for a and b and we will draw and see different. For that what I am going to do is, first I am going to keep b as a constant. Any number can be selected. Therefore just kept it as b equal to 1. Now different values for a we will use and we will observe what is happening. We concentrate more on the point of intersection of graph and x-axis. When b is equal to minus 1, a take different values as 1, 2, 3, 4, the equation, we can see that the changes in the equation, that is minus x minus 1, minus 2x minus 1, like that different equations are forming and the graph is going on moving along the x-axis. Every time we can observe that the graph intersects x-axis except at a point a equal to 0. When a is equal to 0, we have ruled out that condition a equal to 0 is not a linear equation. Now we will give different values for b. When we give different values, the graph moves along the x-axis and the point of intersection is exactly 1 point. And the 0 is the x-coordinate of the point of intersection. Every time we can observe that the graph intersects x-axis exactly at 1 point. So we conclude with this graph. For a linear polynomial ax plus b, a not equal to 0, the graph is a straight line which intersects the x-axis exactly. Consider namely the x-coordinate of the point where the graph intersects the x. Therefore, the linear polynomial ax plus b, a not equal to 0 has exactly 1 0, namely the x-coordinate of the point where the graph intersects the x. Now let us consider a second degree polynomial, that is a quadratic polynomial. Ax square plus bx plus c. Here we can find a, b, c are three constants. We have to give different values for a, b, c. We get different graphs. The graph of the second degree quadratic equation is the shape of a parabola, which are very much related with our daily life. You know, rainbow, semicircular, then still we can say that it is a parabolic shape. Similarly, how a dolphin dives, it the shape of a parabola. Again, how a ball bounces, shape of a parabola. In Vigaland and all, if you see the roller coasters and all, most of the shapes are parabola. Therefore, there is really related lot of in our daily life. The shape is really related with our daily life. Therefore, let us see what happens when B and C are keeping constant and A is going on changing. When A is going on changing, please observe what happens to the graph. When A is negative, the graph is open downwards, and when A is positive, the graph is open upward. Now, when we consider about the point of intersection, some places the graph intersect at 2 points, some places the graph intersect the x-axis exactly at 1 point, and some places the graph intersect at no points. Now let us keep A as a constant, any value, A equal to 1 given. Now let us change B and observe. Now we can see that the graph intersects at some places 2 point of intersections, Some places no point of intersection. And if we keep some other value for A, A is given -1. What is happening to B? The graph is downwards. More than that, it intersects at present 2 points. Now let us see what happens when C is going on changing. When C is going on changing, the graph is moving downwards as well as upwards by keeping its open downwards. Now we can see no point of intersection, 1 point, 2 points. Now we can conclude by observing when A is positive, the graph upwards. When A is negative, graph is downwards. For different values of A and B, the graph, some cases, either it intersects at 2 points or 1 point. 1 point is coming, both the points are equal. 2 points comes as equal, then we can say that it intersects at 1 point. Then some places no point of intersection. Therefore, we conclude that a quadratic polynomial can have either two distinct zeros or two equal zeros or no zeros. Now let us consider a cubic polynomial ax cubed plus bx square plus cx plus d. Here we can see there are 4 constants a, b, c, d. We will give different values for a, b, c, d and we will observe what happens to the graph. Here also we concentrate more on the points of intersections other than the shape of the graph. Here we are going to keep B, C, D are constants. A is going on change. Therefore, we will give A different values. When A is given different values, we can observe here what equation is taken and we will concentrate on the point of intersection. See, here we can see for different values of A, the graph intersects x-axis at 1 point. Now we will keep A as a value A equal to 5 and we will give different values for B. When we give different values for B, the graph moves along x-axis and takes different shapes. Again we concentrate more on point of intersections. Here we can see there is only 1 point of intersection. Now we can see 3 points of intersections. Now let us keep B as one constant, any one constant. We will change C. You can see present 1 point of intersection. Now 3 points of intersections. Now we will keep C also one constant. We will change and see what happens when they give different values. When they take different values, here again the graph, some places intersect at 3 points, some places at 1 point, and some places we can find even 2 points. Therefore, we can conclude here that when we change the different values for A, B, C and D, the graph intersect either at 3 points or at 2 points or 1 point. So we can get the result as any polynomial of degree 3 have at most 3 zeros. Now we are going to generalize the result. First we got a linear polynomial has at most 1 zero. A quadratic polynomial has at most 2 zeros. A cubic polynomial has at most 3 zeros. Now a polynomial of degree n. Fine. A polynomial p of x of degree n, the graph of y equal to px intersect the x-axis at most n points. Therefore, polynomial px of degree n has at most n zeros. Now let us answer these questions. The graph of y equal to px is given here, where px is a polynomial. For each of the following graph, find the number of zeros. The graph intersects x-axis at 2 points. Therefore, the number of zeros 2. The graph intersects x-axis at 1 point. Therefore, number of zeros 1. The graph intersects x-axis at 2 points. Therefore, the number of zeros 2. The graph intersects x-axis at 3 points. Therefore, number of zeros 3. The graph intersects x-axis at 1 point. Therefore, number of zeros 1. The graph intersects x-axis at 3 points. Therefore, number of zeros 3. The graph intersects x-axis at 5 points. Therefore, number of zeros 5. The graph intersects x-axis at 4 points. Therefore, the number of zeros is